Hello everyone, welcome to the next lecture on the GATE mathematics. Today I will discuss about the vector calculus, and the first part of this is Green and the Stokes theorem. Myself Dr. Harish, you can simply follow my YouTube channel where you can find the playlist of the GATE mathematics and you can see the PY questions related to the CSR net as well as the GATE examination is available in this lecture. You may analyze that all those questions are related from the 1996 to 23. With the help of the shortcut tricks you can learn from this playlist. So what is the objective is, we will try to solve the vector calculus problem. The first part is how you can solve the line integration over this curve C. So I will tell you a very simple approach how you can solve any of the question whenever this kind of the integration will present in your question. Now whenever this kind of the integration is present, you have the two options. One, either you can apply the Green theorem or you can apply the Stokes theorem. The first question definitely arises is how we can analyze that in the examination whether the Green theorem is applicable or the Stokes theorem. A very simple approach is whenever you have a two-dimension variable, means whenever you have written dx is in terms of dx plus dy, or whenever you have in the R2 plane, then always apply the Green theorem. Whenever you are more than of the two plane, like of the 3 dimension, then apply the Stokes theorem. Fine. Now what is the question is, if you have the 2-dimension plane, then I can written f dot dr is p dx q dy, and then you can apply the Green theorem by using this simple formula: partial derivative of q with respect to x and p with respect to y over this double integration. Make sure P and Q are continuous. It should be continuous over this domain. Fine. P and Q are continuous for over the domain of whatever the domain of this is given to you. So once you can analyze it's a 2-dimension problem, you can apply the Green theorem by using this rule. However, if you have the 3-dimension problem, then instead of the writing, you can write it is as P dx plus q dy plus r of dz, and then you can find the curl of this f, and then you can dot product of the unit normal vector. How I can find this, I will tell you with the help of the numerical example. So that's a very simple approach. You can see after this lecture you will able to solve any kind of the question for this. Today's lecture is not only helpful for the GATE mathematics, but it is also for the IIT JAM mathematics students. So I will cover all those related to the GATE mathematics and the IIT JAM. The last concept is whenever you are trying to find the surface area, that is again the integration of this curve, then you can write as a square root of 1 plus partial derivative of z with respect to x square, and similarly for y square. So based on this 1, 2 and 3 tricks, I can solve each question in a very simple manner. So let's start with the PY questions. Now before that, you can simply scan. If you are a student of the IIT JAM, you can join through this WhatsApp group, and if you are the GATE or the CSR net, you can join through this WhatsApp group. So let's start with this one. So clearly say it's a r square. So and you can say it is a single integration. So we can apply the Green theorem. Fine. It is clear to you. Now firstly you can draw the diagram of the C1. What is the C1 is? This is my x2 plane. X is 0, y is 0. So this is my here. Fine. This is my region of the C1. Similarly, I can draw the region for this is my C1. What is my C2 is? This is my C2 minus 1 to 0. X is minus 1. Y is my minus 1. So this is my C2. Then your integration will be here. So very simple. If I write this x of dx plus x square y plus 2x of dy. Now clearly says this is my q, this is my p, both are my continuous. Fine. So how you can solve that? It's a double integration of this is q with respect to x. What is the partial derivative with respect to x is 2xy plus 2 minus partial derivative of this p with respect to y. So I can say it's a 2xy. Fine. So what is the integration of this is a simple 2x dx dy. What I can say, this is dx dy. Then can I find the value of the alpha 1? That means this double integration of dx dy over the region C1. Alpha 2 is double integration over the region C2. This is my C1. Can you find the area of this? What is that? This is a square. Fine. So once you know this is a square, what is the area of this? That is the length into breadth, or side into side. So that is my 2 into 1. This is my 2. And for this case, what is the length is? This is the minus 1. This is minus 1. So minus 1 minus 1. So it is 2. So both the values are alpha 1, alpha 2 are 2. While this value, this are cancelled. Right options are my D is the right answer. Always draw this diagram firstly. All because you are just start the course, so that's why you always draw the diagram. Once you make a more practice, then there is no need to draw them. Okay, now again you can see it's a single integration and this is the xy, so we can apply the Green theorem. What is the reason is R2, it's a complete R2 reason. Now this is my Q, this is my P. So what is that? It's a double integration of Q with respect to x. So I can say it's a partial derivative minus this with respect to y. Fine. So this into dx dy over the rectangular region R. So I can take minus common. I can written this is del square u. Fine. Now what is the u is? U is my complex, is an entire function. So we all know if f is my entire function, that is analytic function, so then u plus iota v, what is the properties of the f? What is the property of the u and v? Both will satisfy the harmonic function. Fine. If it is a harmonic function, that means del square u is 0 and del square v is equal to 0. So what is the value of this? This is my 0. So what is the right answer of this problem is 0 is my right answer of this problem. A very simple approach. You can simply look about this single integration. Think about whether it's a Green theorem or the Stokes theorem. Look at this one. Again you can see it's a single integration and it's a xy plane. So we can apply the Green theorem. Whatever the problem is there, you can always think about that. I can draw the firstly reason. Y is equal to 1 plus x square. So when x is equal to 0, y is 1, and this is the graph of y is equal to 1 plus x square. Y is equal to 2. This is the value of the y is equal to 2. So this coordinate will be when y is equal to 2, it is my 1 comma 2. Then x is equal to half. This is the line of x is equal to half. Then the positive oriented, your target is to positive oriented, like of this way. Sorry, it's a positive oriented. You can look about this way in the region enclosed by the this. So what is the meaning of that? It's a curve enclosed by the all these three lines. Fine. This is the shaded portion. Now what you can do? You can write this by using the Green theorem. What is that? This is a double integration, partial derivative of this q with respect to y. This with respect to x and this with respect to y. So this is e raised to power y over x plus 1 minus this with respect to y. Fine. So this is dx into over this region R. So this value will be cancelled out. So how you can double integrate of dx into dy? It's a very simple. You can take the limits. I can take the strip on. Firstly I can write as a y. Fine. So I can take as a dy dx. So what is the value of the y on this case is 1 plus x square, and on this case it is my 2, and minimum and maximum value is half to 1. So what is that? It's a half. I can integrate them. It's a 1 minus x square. Fine. So what is the integration of this is x minus x cube over 3. So that's over. So what is the answer of this? 1 minus 1 over 3. It's a half. It's a 8. It's a 24. So I can say it's a 2 over 3. 24 is the LCM. 11 over 24. Again 24 is the LCM. 8. So it's a 5 over 24 is my right answer of this problem. Okay, look at this another one. Again you can see this is the xy plane and the single integration apply. So that's the Green theorem again. I can draw the firstly reason of this. Y is equal to 0, this line. X square plus y square is equal to 1, that is my this circle. And x is equal to 0. And in the first quadrant, that means my portion is here. Clear? Now what are the coordinate of this is my 1. So I can apply the Green theorem. This is my q. I can differentiate this with respect to x. This is my 0. Differentiate this with respect to y. So this is 0. It's a minus 2y dx dy. Fine. So I can say minus of 2 outside. It's a y dx dy. Then you can take the limits. Otherwise change into the polar coordinates. That could be very easy once you change into the polar coordinates. So x is my r sine theta, dx into dy is my r dr into d theta. So what is the limit of this? Circle, radius 1, angle is 0 to first quadrant is my pi over 2. So what is that? It's a minus 2. It's my r square. Integration of the r square is r cube over 3, and integration of the cos minus cos is a sine. This is my 0 to pi by 2, and this is my 0 to 1. So what is the answer of this? Minus 2 is outside. It's a 1 over 3 minus 0. And what is the cos of pi by 2? Cos pi by 2 will be 0. Minus minus plus cos 0 will be my 1. So what is the answer? This is 1. This is my minus 2 over 3 is my right answer of this problem. If you want to solve this by instead of the polar coordinate, then you have to take it as a x. Take the strip on the x-axis. X will be 0. Here x will be my 1 minus y square. Then it will be 0 to y. So y dx dy. Then you have to take firstly with respect to x, y as a constant. Then it will be outside. Then it may take some calculation for you like of this. Then you have to take the substitution and then solve it. But always try to convert into the polar form. That will be easy for you to solve the problem. Okay, now look at this one. Again this is the R2, and again this is the single integration. I can apply the Green theorem. Fine. Now one is with respect to alpha, second is with respect to gamma. Okay. Firstly I can found this value. Fine. This is the double integration. This is my q. I can integrate this with respect to x. So I can take minus as a common firstly. So what is that? It's with respect to x. So I can take as a u over v. You can see that this function and this function both are continuous, because origin is the only point where the function is not continuous, and origin is not the part of the domain. Now you can see what is that? It's a x square plus y square minus 2x square minus, I can integrate this function with respect to y. So it will be x square plus y square minus 2y square over same whole square into dx dy. So what is that? I can open this. It's a minus x square minus minus plus minus y square divided by x square plus y square whole square minus, again I can say the same whole square. It is x square minus y square. So what is the integration of this? It will be cancelled out. So that's a double integration of 0, irrespective whether it's a alpha or a gamma. That's a 0. What is that? It's a ellipse. Fine. So that means this integration is 0 for alpha as well as this integration 0 for the gamma. So that means this part is a 0, this will be 0. So 2m pi will be 0, m will be my 0 is the right answer. Look at this case. Now you can see it's a r cube. It means, can you apply the Green theorem? You can't apply the Green theorem. So you have to apply the Stokes theorem. What is the Stokes theorem is? You can change into double integration curl of f dot n cap. Fine. Now what is the n cap? Firstly we can find the curl of f. We all know how we can find that. I, j, k, partial derivative with respect to x, y, z. So what is the coefficient of this is yz. Coefficient of the dy is xz. coefficient of the dz is xy. So what is that? It's a I cap. Partial derivative of this is a x minus j times this with respect to x is y, and this with respect to is again y, plus k cap. This with respect to x is z, and with respect to y is again z. So what is the answer of this? It's a 0. Fine. So what is the meaning of that? If curl of f is 0, that means this is a 0 into ds. Answer is 0. So there is no need of this part. I will cover one more example in this lecture where you will know how you can find this n cap. So the right answer is my 0 in this problem. Okay, look at this one, which is a double integration now, but it's a r cube. Fine, x, y, z. Again you have to apply the Stokes theorem. So firstly we can find the curl. Fine. So curl is I, j, k. Partial derivative with respect to x, partial with respect to y, partial with respect to z. Coefficient of the dx minus 2y, dy 3x minus 4y square. This is z square plus 3y. So can you find it? So I cap is with respect to y is a 3, with respect to z there is no z, is a 0, minus of the j cap. This is with respect to x 0, this is with respect to z is 0, plus k cap. K cap is there. This with respect to x 3, this with respect to y is plus of 2. So my idea is 3i cap plus 5 k cap. Fine. So by using the Stokes theorem, this will be my curl of f dot n cap into dx d of s, or d of s is nothing but my dx dy dz, dx dy dz. Now I can substitute here. This is my curl f. So n cap, because of this plus sign, I can break this portion into the two part. This plus 5 into n over ds. Fine. Sorry, this is not a it's a just a ds. Now this is the ds, this is my ds. Now you can see that this is what is the n is. In this case n will be my I cap, in this case it will be my k cap. So if it is my here, then double integration of 3 into ds. In this case double integration of 5 into ds. Fine. Up to here I think there is no problem. Now you can see about that. This is with respect to the I cap, that is the x. Fine. Look at that. If you think about this, what is that? This is nothing but x plus y plus z is equal to 1. Fine. Now this is with respect to the x cap. So I can say ds is nothing but my dy dz. So what is the value of the dy dz? That is the x plus y is equal to 1. So I can write this into here, x plus y is equal to 1. Fine. Now, so what is the area of this? What is the area of half base into attitude? So this value is my half 3 by 2, plus this is the value of the k cap. So this area will be my x of y. So what is the x of y will be again x plus y is my 1. So what is the length of this is half base into height. So again it's a 5 over 2. 3 over 2 plus 5 over 2 is my 4 is the right answer. I agree that you may think about that, sir, why you shaded inside portion if it is equality, because it is boundary triangle by the point of this. So we have to make the curve of this curve. So that's a very simple approach. Okay, now look at this another one. Now you can see this is the xy plane. It's a R2. You can apply the Green theorem because a single integration appears. Firstly, draw the graph of this 0, 0, 2, 2, 0, 2. Sorry, 0, 2. X is 0, y is my 2. X is 0, y is my 2. So this is my feasible area. Fine. I say O, A, B. Then I can apply the Green theorem. Partial derivative of this with respect to x partial derivative of this with respect to y, 0. Fine. Dx dy. So I can take 6 as a common. It's a y into dx into dy. Fine. Now you have to take the limits of the x and y. So I can take the limits of the x. Although it's a right triangle, but this value is not equal to half base into height because of this term y. If is present like of this, then you can easily write this is the half base into height area of this triangle. But because of this y, I can write this limits of the y firstly. So I can write, instead of the dx dy, I can write dy into dx. What is the value of this? This is my 2, 2. This is my 0, 0. So this equation is my y is equal to x. So value of the y is x. What is the value of the y is my 2. What is the minimum value of the x in this case? 0. Maximum value of the x in this case is 2. Now you can simplify it. What is the right answer of this? Integration of y square by 2. So y square over 2 and y square over 2. Fine. Now I can take 2 as a common. It will be cancelled out. 3. Integration of 4 minus x square. So what is the answer of this? It's a 4x minus x cube over 3. So can you solve this integration? So what is that? It's a 4. It's a 8 minus 8 over 3 minus 0. So what is that? It's a 4 into, no, sorry, it's a 3 into. It's a 3 into, what is that? It's a 24. It's a 16 divided by 3. So the right answer of this problem is 16 is my right answer. I already told you many times, you always draw firstly this diagram and then you can solve the problem in a very simple manner. Okay, look at this one, which is R2 and it's a line integral. I can apply the Green theorem. What is that? It's the equation of the circle. X cube, x square plus y square is 9. And clearly say this is my P, this is my Q, which are both continuous over this circle. Then I can double integrate of this with respect to x. So what is the integration of this with respect to x is only 7. This with respect to y is only 3. 1 over pi is outside into dx over dy. So what is that? 1 over 4 over pi is my outside. So what is that? Double integration of dx into dy. So can you find what is the, firstly, what is the feasible area? It's a complete feasible area. What is that? It's a circle. And what is that? This is the area of the circle. What is the area of the circle? Pi r square. What is the radius is? This value is my radius is my 3. So that r square is my. So pi will be cancelled out. So what is that? 9 into 4 is 36 is my right answer of this problem. Look at this next one. Again this is a line integral and it's a xy plane. We can apply the Green theorem. What is that? C is a circle of radius 2, center at the origin. Fine. This is given to you. In the xy plane, transfers only the anti-clockwise direction. Fine. So this is my P, this is my Q. Both are my continuous function. Then the value of this, I can apply the Green theorem. Partial derivative of Q with respect to x, 4y square. Partial derivative of P with respect to y. So this is 0, it's a minus minus plus 4x square dx into dy. So I can take 4 as a common. Double integration of x square plus y square into dx into dy. So what is the feasible area is? Is there any portion in the first quadrant? No, it's a complete. So this is my complete. Fine. So what I can do? I can change into the polar coordinates. Find radius is my 2. So I can say x square plus y square is r square. Dx into dy is dr into d theta. So this complete circle is radius is my 0 to 2. Angle is my 0 to 2 pi. So what is that? So 4 is r cube. So it's r4 over 4, 0 to 2. And since angle is a constant limit, so it is here 2 pi to 0. So 4 will be cancelled out. 2 raised to power 4 is 16 minus 0 into 2 pi. So what is the value of the L? L is my 32 pi. And they are talking about the L divided by pi. So it's a 32 is my right answer of this problem. There is no need to solve this like taking the strips on this. Whenever you see the circle or this, change into the polar coordinates. Okay, look at this boundary on the square region. Again you can see xy plane and the single integral appears. So that means Green theorem is applicable. Draw the diagram. 0 0 2 0 2 2 and 0 2. So this is A, B, C. This is O, and the feasible area is my this portion. Fine. Then by using the Green theorem, this integration will be my, this is my Q, this is my P. So Q with respect to X minus P with respect to Y, minus plus 2y dx into d. Fine. Is it okay? Now what you can do is, I can take the strip, or you can like of this dx dy separate plus y dx into dy. What is that? This is the area of this OABCD. This is the square. Fine. The length is 2, width is 2. So what is the area of this square, side square, plus this is not an area because of this term y. So I can take the strip of, so I can write this as, say, firstly dy firstly and then dx. So I can take the strip of this. What is the value of this y? 0. Value of the y at my 2, and the limits are also x of this. So what is the integration of this is y square over 2 from 0 to 2, and with respect to x is a constant value, so it's a 0 to 2. What is that? 4 plus, it will be cancelled out, so it is a 4 minus 0, 2 minus 0. So what is the answer of this? 4 plus 8. So 8 plus 4 is 12 is my right answer of this problem. You may think about like this way. There is no need to separate them. You can write strip also, like 1 plus 2y. I can written as a dy into dx. So what is that? Limits are my 0 to 2, 0 to 2. Again you will get the same answer, like y plus y square. Outside limit is my here from 0 to 2. So what is that? It's my 4 plus 2. 4 plus 2 is 6, minus 0 is this. So what is that? It's a 6 into 2. Again is my same answer of this problem. So you can solve either, you can open this, or you can simply solve this by here. Okay, look at this one. The work done. What is the formula for the work done is F dot dr. So you can see it's a single integration. Fine. So whenever this is a single integration, you can apply the Green theorem. What is that? This is my P and Q. Both are my continuous upper half of the circle. So this is the only upper half of the circle. This is my circle. What is my feasible area is? This is my feasible area only. Fine. Say A to B. Then by using the Green theorem, I can differentiate this with respect to x, because this j means that is a dy, and this means it's a dx. So partial with respect to x, it's a minus of 2x, minus partial derivative with respect to y, it's my 1 into dx dy. So I can take minus as a common, 1 plus 2x dx into dy. Now either you can take the strip, but it's better you can change into the polar coordinate, or again because it's a 1, I can break it separately, minus 2 I can take as a common, x dx into dy. What is that? This is the area of the hemisphere. What is the area of this hemisphere is pi r square. What is the radius is 1. Fine. Now for this case I can change into the polar coordinate. So what is the x is r, cos theta, dx into dy is r dr into d theta. So it is a minus pi over 2 here. What is the limit of this? Circle is radius 0 to 1, angle is 0 to pi because of the only hemisphere. It's r square. R square integration is r cube over 3, 0 to 1. It's a cos. Integration of the cos is sine from 0 to pi. Fine. Now clearly says that whenever you put sine pi is a 0, sine 0 is 0. So this value becomes my 0. So the only answer becomes is my minus pi by 2 minus 0 is minus pi over 2 is my right answer of this problem. Okay, look at this one. This is a recent GATE 2023. See the curve of the cylinder and the plane here. Now you can see dx, dy, dz. I have to apply the Stokes theorem. So what is my curl of f? I cap, j cap, k cap. Partial derivative with respect to x, with respect to y, with respect to z. Always remember, whenever there is a single integration appears, always apply the Green or the Stoke, because it's a 3 dimension. So I apply the Stokes theorem. What is that? This is sin x plus e raised to power x. This is 4x is a e raised to power z cos square z. So what is that? It's a I cap. This is a 0. This is a 0. Minus j cap. J cap x. There is no x, 0. There is no z, 0. Plus k cap. K cap partial derivative with respect to x is 4. With respect to y there is no term, is a 0. So that is my 4 k cap. So by using the Stokes theorem, this will be my curl of f dot n cap into ds. So what is my curl of f is 4 k cap. So n, what is my n cap? N cap is again my k cap. So if this is my k cap, that is a z axis, dx will be my dx into dy, because this is my k cap. K cap means that is a z axis. Fine. So what is that? This is a double integration of k into k cap is here of this. Now what is the graphical representation of xy is circle. Fine. This is the feasible area. So I can take 4 as a common. What is that? This is the, what is that? This is the area of the circle. What is the area of the circle? Pi r square. R is my 2. So 2 of square. So what is the answer of this? 4 into 4 is 16. Pi is my right answer. But they are talking about the alpha. You can compare them. Alpha is my 16 is the right answer of this problem. Look at this another one. Now they are talking about the surface area. What is the surface area? As I told you, surface area of z. So partial derivative of z with respect to x square and z with respect to y square into dx dy. That's over. So what is that? 1 plus 2x is a 4x square, 2y is a 4y square, dx into dy. So what is that? Z is equal to 0. When z is 0 means x square plus y square is 0. When z is equal to 1 means x square plus y square is 1. So can you draw the graph of this? This is a 0, 0 for the first line and 0, 1 for this line. So this is my feasible area. So what I can do, I can change into the polar coordinates. So what is the polar coordinate of this? I can say this is my 4r square. This will be my dr into d theta. So what are the limits? The value of the r is my circle of radius 1. Angle is my complete of 0 to 2 pi. So how I can solve this? I can multiply 8 so that this into 8r. Fine. Now you can see the derivative of this is appear directly. So this integration becomes my 1 plus 4r square raised to power 3 by 2 divided by 3 by 2 into d theta. Angle is my 0 to 2 pi and here limit is my 0 to 1. So what is the limit of this? 0 to 2 pi. 2 over 3 is here. When you take 1, it is my 5 raised to power 3 by 2, and when you take 0, it's a 1. Now this is a constant value, so it is my 2 pi over 8 into 2 over 3. This value will be my 5 root 5 minus 1. So 2 to 4, 4 to 8. So the pi over 6, 5 root 5 minus 1. So you can use the round off figure. What is that? Root 5 is my 2.7, and then you can use the calculator, you can get your right answer as here. Look at one more question here. Let S be the portion of this plane which lies inside the circle. Surface area of is given to be my this. So again I can apply, this is again the same rule. Fine. Z with respect to y into dx dy. So what is the value of partial derivative of z with respect to x? Is a 4. 2 square is 4. This again 4 into dx dy. What is the graph of the dx dy is? It's a circle. Fine. So what is that? It's a 3 double integration dx into dy. So what is the area of the circle? Pi r square. Radius is my 1. So this is into 3 pi. And this value is given to you as alpha pi. What is my alpha? The value of the alpha will be my 3 is the right answer of this problem. So this is a very simple way you can apply the Green theorem as well as the Stokes theorem. I hope you enjoy this session. I hope you can like also. We will see the next lecture on the vector calculus again. Now the topic will be on the divergence theorem. I hope you can like, share and comment on my video. Best of luck students. Happy learning.